Hello. Ugh. Hello. Actually, hold on. Give me a second. Okay. I'm back. Okay, so hey. What up, dude? It's me, SolarLoon. It's me. I'm an independent game developer. I'm the creator of Master Plan. I'm the creator of Tetra 3D. I'm the creator of this game I'm working on. And I'm making it in Go, and I'm using my own 3D renderer called Tetra 3D, and it's going well. And I'm also using WASM WebAssembly to write, well, basically to load the game code and script, which will be written in Go as well. So it's kind of like I'm making almost all of the layers of this kind of like custom engine myself. Let's get some music going, and then I'll show a little bit of what I've been working on. This is a little bit of a banger. Okay, so just a couple things real quick. I'm not sure if this will translate to real gains, but something I just noticed was when I was running the stress test for Tetra 3D. This is what the stress test currently looks like. It's a lot of cubes. They're multi, there's a lot of triangles there, and they're all like merged into one draw call. Well, one draw call, I guess, per cube. So each cube is 5,000 faces, 5,000 triangles or so. I guess maybe 10,000, and so we're only looking at half. But yeah, we're basically looking at 15,000 triangles here. And we're getting 49 milliseconds in terms of total render frame time. And the lighting frame time, I noticed, was 6 milliseconds, 6 to 7 milliseconds. And I'm like, wait a second, why is there lighting? Why are we spending time on lighting when there's no lighting in this scene? All of the cubes are completely shadeless. So I went to this to the render loop, and I'm like, wait a second, I'm timing like the way it was before. I was timing things even if the lighting was not being done, and I'm like, wait, if I just time things, let me move it so that I only time things when the lighting is being done. And I was also doing this where I was like resetting the vertex light color buffer for every triangle, and I'm like, well, I only need to do that if I'm actually drawing the triangle using that lighting. If it's shadeless, then I don't apply the vertex lights. So just those little changes got it from 20 FPS in this scene to now 26, 27 FPS. And lighting frame time is at 0, which is exactly correct. So that's cool. that's real dope. To go from 20 FPS to 27 FPS is almost like 50% better. It's like 35% from 20 and some change to 27 is like 30 something percent better. Almost getting into 40 if it gets to 28 FPS. So that's a significant improvement on rendering basically shadeless cubes, and it feels a lot more responsive, feels a lot smoother just looking at it. So that's really cool. I also did a couple other things to really optimize collision detection. One of the things was I was still using broad face. I was still like testing for triangles in broad face collision detection. Okay, so I guess what I was, just to kind of roll it back. Oh, we hit 30 FPS at some point. That's fantastic. So basically, I remember I implemented broad face collision detection at some stage, maybe a year or two ago, because I was like, okay, well, that should help to make collision detection faster, because we can kind of like pin down fewer of the triangles. We don't have to test against the entire mesh. We can just test against those that are closer to the colliding object. I feel like broad face collision detection might be best suited for larger games or for higher poly games, because at lower polys you're basically storing more data at lower poly counts. You're storing a lot of data and querying that data when you probably don't need to, and that querying process can maybe take longer than just testing the triangle. So basically what I did was I removed the utilization of broad face collision detection, that broad phase from capsules and I think AABBs, and then I also did it for spheres and got a significant speed up. So what used to take 7 milliseconds now takes 3 for spherical collision detection. And this isn't like huge, it's just basically like, dude, I did not mean to leave it like this. But I guess this is fine. We can test it. So you can see here, yeah, we're moving the sphere here. We're getting 3 to 2 milliseconds, testing for a collision 1,000 times in this game frame, which is really good. We're getting some good frame times. Before it was like 7 or so. And then the capsule is also only 4. It's like 4.3, 4.5 or so. It used to be 10. It used to be like 10.5 milliseconds. So I managed to get things dramatically faster, which is great. So it's almost free to do collision detection. We're getting 9 microseconds. So you do it 1,000 times and you end up with 9 milliseconds. So you're still hitting 60, but you know, well, it actually you're only hitting 3 milliseconds. So I guess it must not scale linearly. Yeah, so that's good news for me. Something else I did was basically when we do collision detection for capsules, previously I was calculating things a lot more like all the time and I started caching some basic stuff. So if we look at actually it's in Collider DT capsule triangles. So here what we're doing is we're getting the top and bottom of the capsule, and previously we were just kind of like checking to see if it collided with the, like if we're checking a capsule against a triangle mesh, previously we would check to see if it collided with an AABB. It's better to just do we actually even use this anywhere? I guess we do. It's faster, rather than checking to see if we are colliding directly with the AABB of the triangle mesh, we can just check to see basically if we're crossing the boundaries of the dimensions of the mesh, and if not, then we can just abort early. And then we also, like I said, I'm caching these values. So previously I was doing this math here every time I called for the capsule's top or bottom. Now we only need to do this basically when the capsule moves. If it doesn't move, then we can just use the cached version of these values, which is good. That means that basically we can avoid doing this math all the time, which again results in a massive time save. So we end up with something, like I said, it used to be 10.5 milliseconds to test for collision 1,000 times and move the object like so. Now it's three milliseconds. It actually probably would be even faster if we didn't move the object. Let's see. That's about the same. I guess because we're testing. We're not actually colliding with anything here. If we were colliding, that would be different. Yeah, and now it goes up to 10 milliseconds. 10, 11. Cool. So we're getting a much better outcome, much better result, which is very good because basically the faster we can check for collisions and avoid them and stuff, the better performance we get. Bruh, what is this? What is this behavior? Oh, I think I know what the issue is. Okay. If the top minus the radius. Let me see. If the top of the x minus the radius, yeah. Or plus the radius, or minus the radius, or plus the radius, or minus the radius. Oh. I'm not sure how this is. Oh, because top and bottom have different lengths of text. I was like, how am I going down and it's not the same? Okay, here we go. All right, so this is minus radius. This is, whoops, plus radius. This is minus radius. Cool. Yeah, it should work. Okay, it's fine. It is not working. Is this the issue? Let's see. No. Okay, why? Oh, am I not? Yeah, I'm not moving anymore. That was part of it. Okay. Gotta move on the MTV still. There we go. Cool. But that that fix was, I think, important. Yeah, we need to add in the radius, because if we didn't add in the radius, then collision is going to be a little wonky, because it's not gonna. Well, no, I guess it would be fine. It would just be a little. It's a little wonky, I guess. Did it used to do that, or is this new jank? me see. Okay, no, it was always like that. Okay, that's fine. All right, cool. Yeah, so we can commit these changes. Yeah, very cool. So this is very nice. This means things will run better. That's what we're always after. Things running better, running faster. Cool. Now, oh, I guess actually I want that open. Now this is what I was working on recently. Basically re-implementing this game kind of from scratch. Cool. So everything's looking about the same, but things should run better now, which is good. Someone also submitted an improvement for matrix multiplication that uses SIMD SSE, like SIMD mathematics. Yeah, my brain is, I'm tired. Basically, it runs faster. It runs faster. So, yeah, this is running pretty well. My character is, of course, like all the way through the ground. That's kind of intentional. I'm just like testing out raycasting and collision detection and stuff like that. And so I was kind of what sent me down this rabbit hole. It's not really a rabbit hole, but you know, before this was like maybe 70 or so microseconds. I was like, I want that to be faster. And then when I would go out into, you know, the void like this, it was also like, you know, 50, 60. I'm like, why is it so high when there's nothing over here? So then I went into the collision code and I'm like, oh, this can be changed a little bit. This could be running a little better. And now it's running a lot better. Now, when we're collision checking all this stuff, but we're nowhere near it, we're skipping a lot of collisions. And then it's only the things that we could collide with that are returning values, and that, you know, raises the time of the check, which is good. Still spending a lot of time in the process because we are essentially converting data from the host process and transforming it. Well, we're converting data from the guest process, the WASM plugin, the game, converting the arguments for the collision detection into strings via JSON, and then deserializing them on the host side through JSON. And I don't like that. The collision check itself is only 27 microseconds, but we're spending 91, we're spending 88 on this process. And we're not even colliding with anything. This is on just waste, wasted energy, wasted efficiency. So we want to avoid that. We want to make it run faster. So what I'm thinking is I want some kind of system that basically allows me to perform a collision check and then probably serialize as little data as possible. What I'm thinking is my current approach toward collision detection is basically kind of like what I have in Tetra 3D, where you can specify different terms. You can specify different like filters, like, oh, the colliding object has to have a certain name, or it has to have a partial name, or it has to have a property with a certain name or a property value or whatever. That works fine. But we want to avoid having to convert stuff to JSON if we can help it, if we can not do that. So what I'm thinking, especially if we don't have to, I mean, well, there's a couple things. You can see that we're also like writing and reading data, which we can avoid doing as well. So I'm trying to figure out if there's a way to kind of do as little as possible to get some good frame times. So in this example, we're sitting at a little bit above, well, significantly more than the cost of the collision detection, because we still have to I guess because we still have to convert it back from JSON, like we still have to call the function. Oh, let me close this real quick. Yeah, like I think we still have to do, this is what's taking time. Like this is what is where our kind of the meat of what we're doing lives. And then this is where we're kind of like spending more time. What if we cut that out? Is it closer? No. The collision check itself counts the conversion of the data to It's about the same if we don't have any terms. Okay. So yeah, it might be just the cost of outputting the results of the collision check to float values, because when we go here, this is what a collision intersection is, and a collision can have multiple intersections with multiple objects, but we're not actually outputting anything, so that shouldn't even, the cost of that should be even lower. Okay, so the collision. Let me move out here. So the collision check itself is 23 microseconds. The collision call is 38 microseconds. So we're adding an additional like 15 microseconds. We're adding another 15. Even if we don't do anything, huh? Is it the reading of the memory? No. We're adding like 13 now instead of 15. 48 to 62, that's like, yeah, 13, 14 microseconds, so it's not significantly different. 13, 14, 13, 14. Okay. So it's not like reading the memory is that it takes any time if nothing is written. But what if something is written? No. Collision call is much higher. The check itself is still small, 42 microseconds. Not too bad. But the collision call is big, 65 microseconds. So we're adding on another like 30 or something to output the data. So I guess what I'm thinking is like, which should I, there's a couple approaches I could take here. One is I perform the collision check in the engine, and then give the results to WASM, which is what I'm doing now. Or I could perform the collision check in engine and give an identifier to the collision check to WASM, which WASM then uses to retrieve the collision data. The only issue is that would require some kind of like system where I have to destroy collisions after they happen, or I cannot store them, or something. I'm not sure exactly what I would do. Like either I'd have to destroy them manually, or I'd have to store them manually. Like what I'm thinking is I create the collision data, the collision check results, and store them somewhere, and then every frame I delete them. Like I delete them to make room for new collision checks, or I store them and I have to call for their deletion manually. So either I store them and I call for their deletion manually, or they're deleted normally and I have to call for their storing manually. Neither of these approaches sound particularly good. So, I mean, I could do like a finalizer. I could work with a finalizer so that when the collision object naturally falls out of Go's garbage collection, it calls for the destruction of the collision object in engine. Let me see, how does that work? Let's see. An example of the use of a finalizer, the runtime set finalizer function for a Golang data structure. The documentation describes the expected signature for the function passed to set finalizer. Well, I can't use a finalizer with the struct because I'm not storing pointers to the struct. I guess I could make it so that it returns a pointer, but ordinarily I would store that. Like my current approach is that all data structures are basically just numbers, and so the structs themselves are not pointers, they're just plain structs. Man, I'm thinking, dude. I'm thinking. I could use the finalizer if I had a pointer system. Like if I moved 2 pointers for collisions, then when the collision falls out of, when it's finalized, it is removed, it is destroyed. It destroys, the destruction function is called on the collision object. That's something I could do. Yeah, that's something I could do, because I'm just thinking about kind of just API stuff in general. I'm looking at like T3D node, right? Well, I guess we'll look at the player's perspective. Like, for Go, normally, if you stop, because there's a garbage collector, if you simply don't refer to something anymore, you don't keep any references to it, then it will eventually be cleaned up. But with my system currently, you have to manually destroy nodes yourself. No, I guess that's for the best, because you can have a node not be referred to in WASM but still be referred to elsewhere. Yeah, just because it's not referred to in your game code doesn't mean it doesn't exist. That's what the explicit destruction function is for. Okay. I guess let's stick with this system. Let's stick with this system, and then if we have any problems, we can always... Okay. Something like that. And then make it so that these take. Something like that. And then we do like that, and then instead this we can do something like that. With a name. Engine.withName. This is more smooth. Terms. Collision test terms. Terms.withName. Terms.name. Terms.name is name partial. Okay, we'll keep things, I think, localized on the settings object. I think we're good on with that concept. Okay, something like that. That time's so bad though. 100 microseconds just for collision checks is crazy. Like naturally, if I say range like 100. Oh, we're printing. We're printing. We're printing here as well. That's right. Well, maybe this isn't so bad. Because we're printing this. Okay, we're not. It's not so bad. 4 milliseconds for 100 collision checks. Okay, that's not bad. That's not the worst thing in the world. All right, so we have some basic collision then. Yeah, filtering is fine. Okay. Okay. So let's fix that raycast. Oh yeah. Value okay. Cool. There you go. Now we can't phase through walls anymore. Okay, it's working. And the update is way lower than it used to be. So this is highly promising. Highly promising. Okay, so let's do some nice stuff. It makes this a little nicer. gonna change real quick. Oh, that's why it's like sticky. Right. There we go, that's better. That's better. Yeah, way better. We gotta fix this bending. It's happening because there's a bug in Blender. Did it get fixed yet? Has it been resolved? I don't think it has. No, I don't think it has. Yeah, no. Unfortunate. Unfortunate. Yeah, there's a bug, brother. So has solidity. Oh, it's not the mesh. That's right. Okay. Here's what we're gonna do. Excuse me. Since when could... Oh, I guess that you could always, yeah. Cool. Let's see. Mesh. What am I looking for? Auto set. I don't think outwards is going to be. Oh, I never actually implemented it. I was like, what's... I gotta double check this, make sure I'm doing this right. What? Since when? It can take bulls? I didn't know that. What? Okay, well. For some reason I thought I couldn't. Oh, it can take bulls probably here. It just can't take them here. Maybe this is what I'm thinking of. Maybe it's working? Let's see. Oh yeah, it's working. You can see it really heavy here. Yeah, okay. Cool. Okay, let's see. Back to the player. Trying to navigate around here to get to these specifically. Keep falling in the water and I have no like means of escape. Oh, I can jump, can't I? I cannot jump. Okay. I'm just trying to check to see like is basic collision working. Can I walk into? Yes. Okay, cool. All right, so it is working. Okay, let's get some more helper stuff to help us make this work right. It requires everything? Let me see. Okay, I don't want it to have to require everything. go. That's a little better. Does this feel right? Let's see. Okay, I guess this works. Oh, time units. Or just numbers, that's right.
Okay. Maybe that'll help us out. Something like that. Let's change up the music.
So 1 second at 60. Value should be.
Okay, I think it's working.
Need to make these unexported. Let's see.
Cool.
Trying to think about how this should work. Let's see.
This works, but now that I'm thinking about it, the timer system probably will not work correctly if the TPS changes, yeah. Let's see. $360. Okay. Yeah.
Oh, that was hard too.
It's taking a long time to download, as unusual. This is an interesting case here where I guess I would have to make an API for timers because it's like I don't have to do that, but I feel like timers are kind of basic, and I want them to have I want them to update by themselves. I don't want you to have to alter your game to like blend them in here, much like, well, the action system also should probably be automatic. Alright, well, if it's not gonna work, if I'm gonna have to do some stuff, then that's fine. Right. That's right. That's right. Okay, okay, not bad, not bad. Kind of bad. He's wedged. But it's getting there, it's getting there. Update is nice and fast, that's good. I think he's too low. There might be a couple reasons for that. Okay, so I'm gonna stop here because I realize I'm gonna have to think about like the animation player and how I'm gonna manage that exactly. Anyway, this is going pretty well. It's going pretty well. It's performing really well, which is great. And we're getting the API together, which is great. It's, you know, we're able to do a lot right now. But animation still needs to be implemented, which can, you know, won't take too long to just like just kind of walk through and implement that stuff from this. Yeah, it's not too much, I don't think. Maybe I'll have to see about that, but yeah, it shouldn't be too much. It's just a matter of just getting things done. Wonder how exactly I'm gonna handle like chaining animations. I'm not sure about that. Well, I guess it would just be the same kind of concept. something like this, because when you play an animation, you get returned an animation callback sequence, so you can chain things together. And so I'm wondering if it's like how would I translate that to pass through WASM? Hmm. Yeah, those callbacks between that cross the border, that's going to be a little tough. Might have to come up with another solution. Okay. I'll have to think about this a little bit more. Thoughts are coming to me, but yeah, I'm going to have to sequence animations, so I'll have to come up with something. And I like callbacks, but they can't cross the barrier, so I have to figure out like how to approach that. Anyway, thank you very much for watching. I've been Solar Loon. I'll catch you guys on the flip side next time with more development, and hopefully I can get this done in the next week or two. Kind of get it back to where it was. Once all the technology is there, it's not too hard. It's just implementing all of the stuff that I already had. That's just going to take some time. But once it's there, it should be pretty easy to get back up and running, and it should perform much better than it used to. All right, well, thank you very much for watching. I'll catch you guys on the flip side next time. And yeah, check out Tetra3D on github.com/solarloon/Tetra3D. Alrighty, see ya. Bye.